So these are the notes, which you can't see, for 8, and we're going to solve quadratic functions by using the quadratic formula. Hopefully you watched the 2 videos before watching these notes, because there's a little Pop Goes the Weasel song that you just have in your head and you can't get rid of it. But let me explain something first. I need to back up a little bit, and I need to give you an example. So I'm just going to write this on another piece of paper so you can see what I'm doing. You don't necessarily have to write this down just yet. But I want to explain why we're going to use this formula. There are problems out there which you have not experienced any of them yet. So I'm just going to write one down, m squared minus 5m minus 35. So I want you to think about this. I just want to show you why we're going to use the quadratic formula on some of these problems. If we tried, we're going to say, okay, a times c, that's negative 35, b is negative 5. So we're trying to find numbers that multiply to get a negative 35, but then add together to get a negative 5. Well, okay, so that, I know one of them has to be negative, but so if I think about factors of 35, that's 1 and 35, 5 and 7, and that's it. There's none of these that are 5 apart. So our typical way of factoring, of saying, okay, m minus something, m plus something, there's no way we can factor this and get whole numbers or integers. So there is another method that we can use called the quadratic formula, to where this quadratic formula will work with any quadratic. Okay, not every quadratic is factorable the way we've been doing it, but now we're going to teach you a way you can solve any quadratic. Sometimes it's faster, sometimes it's not. But sometimes I look at it to say, can I find numbers that multiply to get negative 36, but are 5 apart? So I'm going to show you this one using the quadratic formula. Even though this one, you could probably solve it faster by factoring, there are going to be some that you can't solve by factoring. So I do want to warn you, when we get down here, get a calculator ready, because there's some that you're going to have to use a calculator on. So the quadratic formula, if you watch the little Pop Goes the Weasel, the negative b plus or minus the square root of b squared minus 4ac all over 2a. It's like in your head. So if you hadn't, you need to go watch that. So here we need to decide. First of all, we need to make sure it's in standard form. Okay, so these are in standard form. This one's not, so we'd bring that 12 over. This one's not, we'd bring the 12x over. Then it's all about identifying the a, b, and c term. Okay, so identify. So a is 1, b is negative 5, c is negative 36. So identify your a, b, and c term. Watch your signs. And then all it is plugging it into the equation. And then there's a little bit more. So we're going to do the opposite of b, which is the opposite of negative 5. This is going to give us our x-intercepts. Okay. Opposite of negative 5 plus or minus. Oh, God, I'm so sick of my dogs. Sorry, guys. Okay, b squared. Oh, somebody must be delivering something. I don't know. Negative 5 squared minus 4 times 1a times a negative 36. That looks like 11 times 1 times a negative 36. Sorry, I'm trying to... Darn it. Negative 36. Okay, all over 2 times 1a, which is 2 times 1. Now, so we're going to have opposite of negative 5 is 5, plus or minus the square root. Negative 5 squared is 25. Oh my God. And then negative 4 times 1 times a negative 36. Well, that's going to be positive. So that's going to be 4 times 36. It's going to be plus 144. Then you need to add these. So you have 5 plus 24. 25 times 144 is 169. Then here's the square root of 169. Now you can use your square root key. On these, you're going to do shift, or if you know what number times itself gives you 169. 169. Now this turns out to be a whole number. That is, 169 is a perfect square. So you're going to have 5 plus or minus 15, which means Oh, wait, I forgot to divide by 2. Shoot. Okay, so which means, so all those are divided by 2, which means this. You're going to have 5 minus 13 divided by 2 and 5 plus 13 divided by 2. Okay, now 5 minus 13 is a negative 8 divided by 2. Negative 4 is going to be a solution. 5 plus 13 is 18. I'm running out of room. 18 divided by 2 is 9. So negative 4 and 9 are our zeros. So negative 4 and 9, those are our x-intercepts. I agree that this one would have been easier just to factor. I wouldn't have done all this work. Some of them you can't factor though, so that's probably a bad example. But, so negative 4 and 9 are the two places that they'll cross the x-axis, okay? So your solutions, your roots, then be negative 4 and 9, or zeros. They might be calling them zeros. Okay, so let's try another one. Identify your A, B, and C. Your A is 2, B is negative 7, C is 6. Okay, now the opposite of B, plus or minus. Now you don't have to memorize this because you'll have this on a reference sheet. You'll always have the formula, but that's the Pop Goes the Weasel helps us remember it. B squared, negative 7 squared. I'm going to move this. That's in my way. Negative 7 squared minus 4. This is your discriminant that tells you how many solutions you're going to have. Okay, 4 times A, which is 1, C, 6, all over 2 times 2, 2A, 2 times A. Opposite of 7, plus or minus, square root of 49, negative 4 times 1 times 6 is a negative 24, over 4. Then you have 7 plus or minus, now 49 minus 24. I don't know, my subtraction's terrible, especially if I'm not really with it. Okay, 25. Ooh, this is another square root of 25, over 4. That means, now square root of 25, that's perfect square. So that means this is factorable. So 7 plus 5 divided by 4, or 7 minus 5 divided by 4. That's what that plus minus means, that you have the positive and negative root, because this parabola is going to cross most of the time in 2 places. 7 plus 5 is 12, divided by 4 is 3. 7 minus 5 is 2 divided by 4. Careful here. 2 divided by 4 is 1/2. So your two solutions here are 3 and 1/2. Okay, so wait, do I have a negative? Is something wrong? Opposite of negative 7, 7. Okay, I'm looking at the answer key that I was given. Hold on, the opposite of B. Nope, they had their answer key wrong. This is correct. Okay. So now, this one, number 2, here's where you're going to need to get a calculator ready. Okay, so this one, when it comes out to these two, that means it's factorable. Like you probably were able to factor that. Now this one, so you need to do 3x squared plus 4x minus 12 and make that equal to 0. Now we're going to identify our A, B, and C, plug it into the formula. Opposite of B, plus or minus, square root of negative 12 squared, minus 4 times the 1. Oh, no, not times 1. Why am I doing that? Times the A, which is 3, times the C, which is negative 12. All over 2A. So 2 times 3. Now, negative 4 plus or minus, negative 12 squared is 144. Negative 4 times 3 times negative 12 is, back up. Dang it. This one had too much going on. This is a positive 4. I'm like, wait, that's going to be 0. That's not going to be good. Okay, so sorry, back up. Erase. Hope you're writing in pencil. That's why I wrote in pencil in this one, because I make mistakes. Okay, 16 16. Now that's a negative 12 times a negative 12. That's a positive 144 over 6. Now 16 plus 144. 16 plus 144 is 160. So you have a negative 4 plus or minus the square root of 160 over 6. Okay. 160 is not a perfect square. There's no number times itself that gives you 160. So here's what happens. We're going to do a negative 4 minus square root of 160 over 6. And then a negative 4 plus 160, square root of 160 over 6. You can leave it like that. Those can be your answers. Or use your calculator, which I don't know what my calculator just happened. Oh, it just dropped. One momento. Okay, my calculator dropped on the floor. All right, here we go. Here's what you want to do. The square root of 160, the square root of 160. So if you do shift, x squared. Now check your calculator. You might not have to do that. You might have to hit, oh no, I'm doing second. Second and that, some of them have a shift. So 160 is 12.6, about that. So you're going to do a negative 4 minus 12.6 over 6. Okay, so a negative 4 minus 12.6, that's going to be a negative 16.6 divided by 6. 16.6 divided by 6. So that's going to be approximately 2.76. Do I have a negative? Yes. So it's going to be a negative approximately 2.76. Okay. The other one is going to be square root of 160, which I just had here. 12 point. So negative 4 plus 12.6 over 6. So a negative 4 plus 12.6 equals, divided by 6, 1.43. So your other one is going to be 1.43. Okay, so I'm going to probably stop here. Just know that when you get to one that's not a square root or a perfect square, then it's going to come out to a decimal. It's going to come out approximately. So it's going to cross the x-axis approximately here. Okay, so try these other three. And let me see. I'm going to look at the answer key real quick. I will let you know. These two should come out to integers or maybe even a fraction. This one though, this one will come out. You'll have to use your calculator for your decimals. Okay, will be decimal. Okay, so I want you to try it. Let me know. We'll definitely do these more in class when we assign these. Okay, but that is the quadratic formula and it's plugging it in. But this is the part that I think you might have a little issue with.